Assalamu alaikum everyone, welcome to mathematics, and today we are here with another paper for A levels. Today the paper we are going to solve is for pure maths, paper code 9709, variant 12, February March 2025. Okay, so let's begin. So starting with question 1. Question 1 says a curve has an equation y is equals to 5 plus 3x minus 2x square. So this is the equation of this is a quadratic equation. Okay, and a straight line has an equation y is equals to kx plus 13, where k is a constant. Find the set of values of k for which the curve and line do not meet. Okay, so whenever we are being given two curves equation, two graphs equation of a curve and equation of a line, or equation of two lines, or equation of two curves. So whenever we are dealing with two curves or two graphs, and we are concerned with somehow the point of intersection. Yes, they are saying they do not meet, but yes, we are discussing about the point of intersection, like either they have one point of intersection, two point of intersection, or no point of intersection. So if we have a case like this, they say they do not meet, means the line in the curve might be like this. Most precisely, it should be like this. How I come to know that this is a upside down parabolic curve is because it is minus 2x square. So minus of a with the x square, like the coefficient of x square decides what will be the shape of your quadratic curve. So here it is minus 2, so that means it is going to be an upside down curve. Okay, so the line must it is better to draw it here, okay, because these lines could be extended as well, so it makes more sense. So whenever we have to discuss about the point of intersection, what we do is we will be equating the two equations to have an equation, so that we can apply the discriminant on that equation to get the points of intersection or no point of intersection. Okay, equating both equations, 5 plus 3x, because we have left hand side both equals to y. Okay, so we can equate the right hand side. So 5 plus 3x minus 2x square equals kx plus 13. Now let's rearrange this. We will be getting 2x square plus kx. I am just shifting it on the other side to make it a positive x square term, and plus kx minus 3x plus 13 minus 5 equals to 0. So it will become 2x square plus k minus 3 whole x plus 13 minus 5 is 8. Okay, so this is your quadratic equation. Another quadratic equation that whenever we get after equating two graphs or two curves, we get this equation, so we can apply the discriminant on this quadratic equation to get whatever the condition is. Here when they say they do not meet, that means the b square minus 4ac, that is your discriminant, must be less than 0. It is greater than 0 when we have two points of intersection or more, and if it is equals to 0 if we have just one discrete or unique point of intersection. Okay, or like solution only one, maybe you can have repeated roots. So, and we use discriminant less than 0 if the lines do not meet, if the curve and the line do not meet. Okay, so let's apply that. What is b? B is this, a is 2, and c is 8. So apply this. B square will be k minus 3 square minus 4 times 2 times 8 must be less than 0. Now we will be expanding this k minus 3 whole square. It will become k square plus 9 minus 6k minus 2ab. Yeah, okay, then minus 4 times 2 is 8 and 8 times is 64, less than 0. Now solving it further, k square minus 6k and minus 55, 9 minus 64 is minus 55, less than 0. Now it seems to be another quadratic equation in k, and yes, we were required to find the set of values of k. So yes, we need the quadratic in k so that when we solve it, we get the values for k. So this is your quadratic equation in k. Now factorize it, like make the factors of it. Which two numbers when multiplied should give you 55k square and when added give you minus 6k? So it must be some negative number, a bigger number. So minus 11k plus 5k. Minus 11 times 5 will give you minus 55k square, and minus 11k plus 5k will add up to minus 6. So these are less than 0. Now taking k as common, so k minus 11 plus 5 common will give you k minus 11 as common. Okay, so this will give you k plus 5 or k minus 11 less than 0. Okay, what happens now? As this is an inequality, we cannot just do it like this, that k plus 5 is less than 0 or k minus 11 is less than 0, and then we get it to be k equals to minus 5 and k equals to 11. No, we cannot do this for inequalities. How do we solve the inequalities? We always make a graph for it. Okay, and what kind of a graph for this particular inequality will be? As we are making the graph for this quadratic equation now, okay, yes, this factor form is for this equation, so we are going to make a curve for this one. So here for k square, it's a quadratic equation with positive a, because with k square there is no negative. So our graph would be somehow like this. Okay, and as we can see, when we put k plus 5 equals to 0, we get it to be k equals to minus 5, and when we put this equals to 0, we get it to be k equals to 11. So these are your two roots. Okay, so this is minus 5 and this is 11. Now what is this equation telling us? This equation is actually like any quadratic equation, we write it as equals to y is equals to k square plus 2 k square plus 3. For example, here it is y equals to k square minus 6k minus 55. So actually this whole equation is representing y. So what it is representing, that y is less than 0. This whole is less than 0. So that means they are referring to a region where y is less than 0. So that means these are the points on graph where y is less than 0. Till here this y is positive, and below this x-axis this y is negative. So in this region, what do we have the values for k? That k is greater than minus 5. Okay, here the values are greater than minus 5 and less than 11. So we will now write the region, the values of k from this region, and this region is representing as the region where k values are greater than minus 5 and less than 11. Okay, Why? Because these were the k values on x-axis and we were taking y values. Okay, this is how the graph was. So this is your final solution. These are the set of values of k which were required in your question, the set of values of k for which the curve and line do not meet. I hope you get this. First we found by equating the quadratic curve in x on which we can apply the discriminant less than 0 because they do not meet. Then we get a quadratic equation in k, and then we solved it to get our quadratic curve from which we can find out the k values from the graph. Okay, I hope you understand this all. That's all about question number 1.